Hello students, so in this lecture we will discuss hydrogen spectrum and helium spectrum. So you know that first start with the hydrogen spectrum. Now you know that in a hydrogen there is one proton and the electron is circling around that proton, and so we take the Dirac number is equal to 1 because there is one proton, and the wave number given as a nu bar is represented by the following formula. Here R is the Rydberg's constant, and the energy of an electron moving in the orbit, this energy has been found, and it's found to be of this value. Now these are the different energy levels. If this is the nuclear, these are the different energy levels. And the deepest one, this n is equal to 1, this corresponds to the ground state, and this is the most stable. Now, based upon where the atoms will shift from n is equal to, it can shift to the second state, it can shift to the third state, fourth state, and fifth state. So, based upon that, we have different hydrogen spectrum series. That means if the atom shifts from, if the electron shifts from the ground state n is equal to 1 to the next excited state, then we have got a Lumen series. In that case, we took the n1 is equal to 1 and n2 is equal to 2, 3, 4. That means you can see that if this is the ground state, n is equal to 1, the electron excited can come from the second state to the ground state, can come from the third state, else come from the fourth state and the fifth state. So all these lines form the series called the Lumen series. Now if we take n2 is equal to infinity, that means if we allow the electron to go out of the atom, then we actually get the value of this R, which is this Rydberg's constant. So if n is equal to infinity, automatically this part will be equal to 0, and this is equal to 1. So we get the value of R is 109,687 centimeter inverse. It's called the Rydberg's constant. Now, similar to that, we can have other series as well. Like we can have a Bauma series. Bauma series is n1 is equal to 2. So now it is happening that if this is the nucleus, so the first state is called the Lumen series, now represented on the second state, and all the other electrons jump to higher exact state, then 2, when they come down, they will form the Bauma series, and for different electrons coming from the different states, we have these different possible hydrogen lines for different lines in the Bauma series, and the wave number limit is n is equal to 4. Here, in the first case, as you can see here, in the first case, that one is equal to 1. But as we have moved to the second state, where R is equal to the following value, but when we have gone back to the second state, so all the electrons in the higher excited state will come back to the ground state. So here n1 is actually is equal to 2. So when n2 is equal to infinity, automatically we will get R by n1 square, that is R by 4. So that is why we are getting the value R by 4, and this is the wave number limit, and this is 27420 centimeter inverse. Similarly, we can get Gaussian series for n1 is equal to 3. Now the wave number limit becomes R by 3 square, that is 9. We have bracket series, and we have different series. So this was all about the hydrogen spectrum. Now, if we go on to helium spectrum, The helium, as you know, has the formula 420. So we can consider it as a mixture of two alkali atoms, and we get four types of series, that is very simple, sharp, diffuse, and fundamental, and they're called P, S, D, and F for each of these two alkali atoms, and the terms that we obtain, we get two terms of one is singlet and one is triplet. We get helium singlet state and we get a helium triplet state, and they're called para and ortho. So, for example, if we take the four n values for n, for the first state it will be the para. For first state will be 1s, second state 2s, 2d, 3s, 3p, 3d, and for n is equal to 4, it will be 4s, 4p, 4d, and 4f. So SP, DF, these are the ground states. And for triplet state, where then we will get three. We get the S state, P state, and the D state. And this is for the para, and this is for the ortho. Now, the postulates for the helium atoms are following. The first postulate is that for each singlet energy state, there is a corresponding triplet, but no triplet state corresponding to the ground state. That means one is this is the first postulate. The second postulate is that triplet states lie a little deeper than the corresponding singlet state. Energy difference between the ground state and the lowest excited state is relatively large, and the triplet state do not combine with singlet atoms. Now, these are the different postulates. Now, coming to into a deeper understanding of the singlet and the triplet state, the ionization potential of helium is 24.5 electron volt, and it is obtained from the limit of the principal series. And the total binding energy of the ground state is 78.9 electron volt. Now, the parahelium, which is called a singlet state, it has got antiparallel electron spins, whereas the orthohelium, which is called a triplet state, is called parallel electron spins. So, antiparallel giving rise to a singlet state, and parallel spins giving rise to triplet states. And there is a transformation from parahelium to orthohelium. The parahelium is at a lower energy state, being a single state. So if it attains energy with respect to collisions, it can combine, it can form an ortho state, and similarly in ortho state, if it loses energy with respect to collision, it forms a para state. So the helium is actually a mixed state. Now, as in helium, we have only two electrons. So the according to Pauli's exclusion principle, the total wave function must be antisymmetric with respect to exchange of spins and spin coordinates. So that is why, to make it antisymmetric, to follow this Pauli's principle, we need to couple the two types of coordinates, that is spin and space. And the space function is symmetric, while the antisymmetric space function is coupled with the three symmetric spin functions, the spin functions. The space is antisymmetric, and it is a single state, whereas the spin is symmetric, and it is a triplet states. So for antiparallel spins, so we have two states, sigma A. A is the first position, B is the second position. So this means that the electron, the first electron is in state A, and the second electron is in state B. And in this case, the first electron is in state B, and the second electron is in state A. So this is quite symmetric. This is called a symmetric space function. It is combined with this antisymmetric spin function. So this plus beta, plus for upspin and minus for down spin. So plus and minus is minus and plus. So if we exchange the spins, the value will become negative. That is why it's called antisymmetric. So for this singlet state, this is for antiparallel spins. That means the spins are parallel. One is in the if the first spin is parallel, the next spin is antiparallel. So it forms the singlet states. But if the spins are parallel, that means if both the spins are in the same direction, then we can form three different states. Like the first one stands for the two states in the up directions, and the last one stands for two states in the down direction. And this one is actually a combination of these two. So we are getting actually three states corresponding to the parallel spins of the electron. Now all these four states, one singlet and three states, are degenerate so long as the Coulomb interaction between the two electrons is ignored. For the ground state, both electrons have the same space quantum number, so that there is a singlet space wave function which is symmetric with the exchange of electrons. Now this space function, to satisfy Pauli's principle, can be coupled only with the antisymmetric spin function. So this is the only antisymmetric spin function. We had put a plus sign, it would have been a symmetric. So this is antisymmetric. But to exchange 1 and 2, the sign will reverse, which is only raised to a singlet state. So this is a singlet state. Hence, the triplet state corresponding to the singlet ground state is missing. However, the absence of a triplet ground state is a consequence of Pauli's principle. So this is quite important. What we are getting is we don't get any ground state for triplet. So this is because of the Pauli's principle. And for all other triplet states exist with the singlet states. So this is for the hydrogen helium spectrum.